better. So good morning, everyone. Another coding game puzzle today, starting a new one. It is called Rearrange a String to Two Numbers. And I have a feeling that it's deceptively simple, yet not all that easy to fix, to solve. So here it is. You must rearrange the digits in the string S into two numbers A and B according to the following rules. A and B, I take this to mean that A and B are both larger or equal to 0 and smaller or equal to 10 to the 18th power. So 1 followed by 18 zeros. No leading zeros, though 0 is a valid number. Okay, 0, 0, 0 is not. Minimize A, then minimize B. And here's an example here. We've got an input of 7, 2, and the output should be 2 and 7, right? Because we're minimizing A, then we're minimizing B. So in this case, it's pretty easy. But here are some other examples here. Let's see. Maximum B. So that's our input right here. And this would be the output. So B would be the maximum, which I'm not going to count, but I'm guessing it's 1 followed by 18 zeros. And then A is basically the rest of the numbers arranged in the smallest possible amount, the smallest possible number. So I had time to think about this last night. I usually choose the puzzle I'm going to be working on before going to bed, so I end up coding it in my head while I'm trying to go to sleep. And I think that in order to minimize A, you first have to maximize B, right? Because we're given a string of numbers, and we know that there is a maximum to what we can have on either the A side or the B side, and it's 1 followed by 18 zeros. So it makes sense that in order to have the smallest number possible, which, would include having the smallest amount of digits in that number, we would want to have as many digits as possible and the largest number in B. So we first start by doing that, maximizing B, then we go over to what's left and minimize A, and then you go back to B and minimize B. Something like that. Let's give it a shot. So first thing we're going to do, I've got the default setup here. I think I'm going to, let's see, maybe we're just going to add what are we going to call this? What would be a good name for, let's just call it rearrange string to two numbers. That's kind of a mouthful. How about string rearranger? String rearranger .test.ts. Let's go with that. Okay. Just setting up a test suite here. String rearrange string to two numbers is our test suite. Okay. So let's use Coding Game's first test case to get us started, which they call 2 digits. And the input is 7, 2, right? So let's call this 2 digits. And need to do this. Yeah, same thing. It's function. Then let's see. We'll call this is our input. It's a string. It's a string. 7.2, right? Yep. And then we're going to be calling our. I'm pretty sure we could just make that a. Yeah, let's just make it a function to begin with. So it's going to be called, what did I say it was going to be called? String rearranger, string, or we're just going to, okay, rearrange strings, string, pass in our input, and that'll be our actual, expected is going to be a string of 2 and 7. And then we do expect that actual is expected. Yes, now we know that's not going to run because we don't have the rearrange string function. So let's rename. Can I do that from here? It doesn't look like it. I can do that here. So what did I say? Rearrange string. Rearrange string. Oops. Rearrange string dot test. Now let's create our implementation. Rearrange string dot ts. Okay, we need a function called rearrange string that takes in well, I'm just going to say input type string. It outputs another string, and we do stuff in there. It's going to complain if I don't. Wait, it didn't complain. It should be complaining. What is this? That's because I don't have the function name here. Export function. What is going on with my linting here? That's interesting. Let's check something here. Weird. Yeah, it looks like my linting is not working. Well, whatever. Oh, it is working. I saw it work here. Export function rearrange string. Why wouldn't it complain? I don't know. So, good. I guess I don't need to do that then. Need to import this. Okay. Now let's run it to see it fail miserably. Right, see? That's what I'm saying. It should be, the linter should be highlighting this and saying, hey, you're not returning. What if I tried to return a number, for instance? Oh, this sucks. Why is my linter not working properly? Do not know. Do not know. I don't know if it's the linter as much as it's the TypeScript. Yes. Let's see here. Start a TS server. Oh well. Have to figure that out, but some of the time. So it wants us to return. Well, let's do that actually. Might as well. Let's return the expected output. We're going to pass our test case. Yay. There you go. So let's add the other test case, which is called too many digits. We're expected to return -1, -1 when it's impossible to solve the problem. Too many digits. Sorry. Too many digits. Here's our input. So that's interesting. The linting seems to be working in the test file. What if I was going to do this, for instance? Function, yo, expecting a string, and we want it to return a string. Ah, see, wow, that is weird. That is weird. Don't know what's the deal with that, but whatever. Okay. Yeah. I do have TS there, don't I? Yeah. Okay. Actual. It's going to be a rearrange string. Should have just copied from the other test. It's pretty much the same setup, right? Go. Expected is -1, -1. And expect actual to be expected. Actual. Okay. Actual. There we go. Let's run this. And it fails. So let's make a pass. So this will basically need a rule if the input dot. Oh man, I've got like, this sucks. This sucks. None of my stuff is working in this file. What about here? If I were to do input dot, yeah. That is muy weird, muy weird. What about in here? If I did const input equals blah 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 blah, and then I do input dot, yep. Okay, there's for some reason this file here is just not not the IDE. The VS Code is not using any linting or IntelliSense on it. So how about this? Let's see if we can try to trick it. And just do, there you go. That's all we needed. Just to rename it. That is weird. If I was to name it back to what it was before, rearrange string.ts. Okay. Okay. Very weird. There we go. We got, okay. And yeah, that's what I was looking for, length. If input.length is a big, bigger than, let's see, our maximum was 1 followed by 18 0, so that would be 19 characters. So if it's bigger than 19 characters, we know for sure. We know for sure that we can't work with it. No, it's actually it's twice as much as that. It's 38, right? Because we've got an A and a B that can both be of 19 character length. Return -1 and -1. Let's see if that will do it. It didn't. Well, well, well. It did not. Okay, let's take a look at our test case here. How many characters do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. And why? Oh, did I? 38. Why does 37 not work? Wait, what's the 10 to the 18th power, which is 1 followed by 18 zeros, right? If I'm not mistaken. I hope I'm not. Well, there's one way to quickly check that, I guess. Actually, I don't know why I keep doing that when I've got a really neat little extension here that I should be using. Quokka is installed. Good. Prepare to be amazed, folks. Just gonna start Quokka on this file. All right, so we'll do, what was it, 10 to the 18th power. Oh, no, that can't be right. Let's try this instead. Wait, why isn't this working? 18. And that gives me 24. How does that work? Oh, silly. No, that's not it either. That's, what is it? What is it? Come on, Phil. Exponentiation operator, yeah. Addition, subtraction, division, multiplication. Exponent, oh, it's 2, yeah, okay. It is 2. Oh yeah, right. The hat thing is a bitwise operation. Oh yeah, there we go. So that gives us, oh man, I can't highlight it. Maybe here. Yes, okay, good. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, I was right. So 1 followed by 18 zeros. So that's 19 characters total times 2. That's 38. So why is it considered too big a number if it's got 37? 37. Oh, right, because my 38 would only be true if you'd be able to do the 10 to the 18th power, whatever that is, gabillion, a gabillion. Otherwise, you'd end up with one less digit, right? Starting with 9, 9, 9, 9, 9, 9, 9. So you'd have 17 digits. Oh, okay, so it can't, okay, the check can't be that easy. So I guess first I need to check if it's possible to make that 1 to gabillion zeros thing. How are we going to do this? Okay. I think that I'm going to think ahead a little bit here. Because if I want to implement this in a way that won't be a complete waste of time, let's take a look. Maximum B. Right. Okay. This is what I was thinking about as I was going to sleep last night. I was thinking of making a... Oh, let me just stop Coca here. It's going to get stop. Okay. How about we make a... And I'm actually going to make that outside the function here. We'll make it a const. And we will... Should I make it a map or should I make it a simple object? Oh, actually, this would be... I could make it an enum. No. No. Let's try a map. That would be interesting. So digits, we'll call that digits. And we will instantiate a new map. Now the map takes, okay, let's give it some types here. The key will be a number, and the value will be a number. Now, I think I can make, I want to instantiate this with a number. Do I even need to instantiate it right away? Hey, FreeSteam. How long ago did I start? I started about 20 minutes ago, roughly. Roughly 20 minutes ago. And I'm just seeing your message now, so I don't know how long ago you typed that in, but you get the email like 20 minutes later. You get an email? You get an email when I go live? I didn't set that up. That's cool. Or is it like a tweet that you get by email? If follow, you get an email. Really? Wow. Twitch does it. Okay. Because I know I'm tweeting it automatically when I go live. But I didn't know Twitch also sends you an email. But you get it late. Okay. Well, good thing I'm on for 2 hours. I'm not that far along though. So it'll be easy for you to catch up if you intend to stick around for a little while. Uh, the gist of it, we're being fed a string of digits, and we need to take that and split that into two numbers. Both numbers have to be as small as possible, but you need to first minimize A, the number on the left, and then minimize the number on the right. And both numbers cannot be bigger than 10 to the 18th power. So it seems pretty simple, but I have a feeling it won't be that simple. Okay, so if I've got my map, I can just go through the string. Never simple, yeah, yeah. Sometimes you think it might be, but like if you look at the description, it's compared to some other puzzles, it's very short. That's it, right there, boom. All right, so my idea now is to have a map and to store how many of each digits we have in that map. The digit being the key and the quantity being the value. So let's try that. We would need to go and is there, I really wish there was a way to iterate like a native kind of functional way on the string, like on the array to iterate it, but I guess there isn't. Well, I could always do that. Yeah, how about that? Eh? Let's just turn it to an array. And then, oh, I don't even need to do that. I'll just split it like that. Actually, it's better if I do this. Boom. But there we go. And then I can just do for each character. Well, let's call it digit since that's what we're dealing with. Digit. And what we're going to do is simply set um, hmm, hmm, hmm. You know what? Maybe it would be better with an object. I could just keep it as a string. Let's have another one here. See how that would work out. Digits obj equals this. So it's an object with a key of type number, which I think I can't have right on an object. That's the thing. Must have a type annotation. Yeah, okay. Take it easy. Take it easy. Key number, and that's going to be a number as well. So it looks like we can have a number as, but I think it just converts to a string anyway. So let's make that a string. And now if I did digits obj, then just do that, then add the digit here, and just go plus equal 1. I think that would do it. It'd be easier a little bit than using the map. Less verbose anyways. And we should end up with a, so let's just call it digits. Boom. And now what? And now what? All right. And now we check, okay, yeah. If we have, so if digits, a dot, okay, use the dot because, okay, if digits, we're looking for 0, is bigger than, bigger or smaller, no. What do we need to check for first? I don't know that there's an easy way to just globally check that. I think I'm actually going to need to implement the splitting of the two strings, so let's do that. So the first thing we're doing, so we're just going to forget about this here. And okay. Okay, so first thing we need to check, because we want to maximize, so let's see here. First, we want to maximize B. Maximize B. That'll be the first thing we need to do to allow us to minimize A, I think. So if we want to maximize B, first let's see if we have enough zeros to make the biggest number allowable. So first, if digits 0 is bigger than 8, bigger or equal to 18, and we also need a 1, and digits dot, not dot, but whatever you call that, 1 is bigger or equal to 1, then we can make B, so we need a place to store B, so let B equals an empty string. Then we can just make our B, why is it a big B? I don't know. Let's make it a small b. B equals, okay, so B equals quite simply 10 to the power of 18. Oh, and I need that to be a string, right? Dot toString. So A has to be the smallest number, aka 0, if possible. That would be the ideal situation. Yeah, A could be 0. But you need to use all the digits in that string, right? So if you give A 0, then all the remaining digits need to be assigned to B, and B can't be higher than 10 to the 18th power. And that's where the, the balancing act, as long as B is less than 10 to, yeah, exactly. Exactly. You got it. So that's why my idea was to first maximize B, right? Because that's the only real way to know what you're working with there for minimizing A. So you maximize B, then you take whatever's left, you minimize A, then you go back to B and minimize B, or you could minimize B right away too, but okay, so right now I'm checking to see if it's possible to have the biggest number assigned to B. If it is, then boom, we're in business. If digits, that's right, and assign this. Oh, and I also need to remove from my super digits object. So digits digits 0 would be minus, no, equals, minus equal, yeah, minus equal 18, and, yeah, 18, and I also need to remove 1 digits. 1 minus equal 1. Although I could do minus minus, nah, I'm just going to do minus equal 1. Okay, so that takes care of that. And if we've got that done, then what do we do next? I don't want to get too far ahead here. I'm just trying to, I have these 2 test cases I want to, and this is a 2-minute digit. So once I've determined that I can't do that, how would I check? How would I check for too many digits? I figure I might as well do the whole thing and then at the end just count and see if we're over. Would that be a good idea? Now I'm wondering if I should be working with numbers until it's time to output the solution and just convert that to strings. Probably not. Probably not, because I'm going to be adding to B and A 1 digit at a time. So yeah, let's work with strings. So sort the digits in order, then pop them into B, then take the rest and reverse the. Yep, that's exactly what my idea was. I'm just thinking here about a way to, before doing all that, maybe finding out if the number's too big or not. But no, I think it's better to just implement the whole thing, then at the end count, or make sure that the numbers aren't too big. And if one of them is, then just output the -1, which is what we're supposed to do if it's impossible to get the proper solution. So yep, let's do that. Let's do that. Actually, yeah, I'm just thinking of something. At first, that was my idea, to sort the digits in order, like in an array, and then pop them in. But I've got this object here, this kind of map or dictionary, whatever you want to call it. And I can just iterate through it in order and empty it. That's basically the same thing, but it's already, oh wait, will it be though? I'm not sure. Are the keys on an object sorted automatically? Huh. They're not, eh? I don't think so either. I think they're kind of assigned in the order you, well, let's find out. Let us find out. That's a good thing to know. Useful knowledge. So let's make an object. Let's make it a let here. Actually, let's just take the same thing here. We'll just name it something different. Actually, we can use it. Duh. Okay. So let's see. We're gonna do digits, and then we're gonna add 3 equals, I don't know, 16. We don't care. And then digits 1. Yeah. That's going to equal 23. Well, 233, whatever. And then we're going to be doing 10, which is equal to, I don't know, 12. Now, if I was to do digits, aha! It looks like it might be. It looks like it might be sorted. right? So, another way to check that would be to do a for key, um, let's see, let key of, or no, in digits. And then just console, or actually I can probably just do this with Quokka. Faux is not defined. What do you mean faux? Okay, there you go. Yeah, oh, see? 1, 3, 10, so it does sort them. Perfect. Wunderbar. So I think I can work with this. All methods that iterate over property keys do so in the same order. First, all array indices sorted numerically. Then all string keys that are not indices in the order in which they are created. Then all symbols in the order. Yep. Yes. Let's just stop Quokka. All right, so I could do, oh, could I iterate in reverse order though? Digits dot object dot keys returns the name of the enumerable properties and methods of an object, yes, as a string array. That would allow me to iterate them in the reverse order. I didn't update my message to, yeah, I did. Rearrange string to 2 numbers, didn't I? Yeah, that's what it says. Oh, yeah, you're right. The message itself, seam carving puzzle on coding game. You are correct. I only updated the link. Thanks for pointing that out. I'm gonna go fix that right away. Or maybe not. Okay, there we go. Timers. Rearrange string to 2 numbers. That's what it's called, right? Something like that. There we go. Okay, so what are you saying here? So they give you an array of digits. It's not an array, it's a string. That's the input. The input is a string. I can easily make it into an array though. That's what I'm doing here actually. And then I'm feeding my I'm building my digits object. So what if I did object dot get own, get to the own property descriptor of the specified object, get own property names, return the names of the own properties of an object. Which is what we would want. Just to make sure we're not getting anything from the prototype. Then we just pass in the object, which is digits, and that should give us, you know what, why don't I leave Quokka on? And that should technically give us, well, nothing as of now because we're not, yeah, I'm starting to Starting to think that it makes lookups a lot easier. But if the only lookup I'm going to do is this here, right? Because this, I need to check how many zeros there are and how many ones. Yeah, you do care to look up here. That's what I'm doing here. You wouldn't, and this is what was tripping me up, right? You wouldn't care to look up anything if the maximum number was 9 to the power of something. But it's not, it's 10 to the power of something. So that means that our maximum number is, yeah, so that's 1 followed by 18 zeros. That's the only case where you would have 19 digits in either your A or your B. That's the only case, right? So let's say you have whatever digits, right, for assigned for each slot, starting at the right and going all the way to the left to a digit number 19. Well, the only valid combination with 19 slots is 1 followed by 18 zeros. You can't have anything else in there, right? So the whole sorting of the array and then just using that doesn't work for that case. So you need to check for that case. Other than that, you're fine. Once you've established that it's impossible to make 1 followed by 18 zeros, then all you need to do is take your 18 biggest digits, sort them, and then boom, that becomes your biggest number. But you do need to check for that. Unless I'm completely wrong and I didn't understand. So you need to check if it's possible to make the biggest possible number, which is 10 to the 18th power. Nope, I think so. You think that I understood correctly? or you think that I'm completely out in left field? But I mean, getting back to the array versus object thing, it would still be possible to do that with the array. 10, yeah, the puzzle would have been easier if it was that, but I think on purpose they made it that way, right? Because it would have been really easy if it was that. It would have just been a matter of doing 2 sorts and you're done. Right? 1 sort, split, then take the rest, sort it the other way, and you're done. And also you can't have leading zeros. There you go. So that's another thing that you need to take into account. But, you know, you might be right. It might be simpler to just... And we don't really care about performance, right? Because this way would have been more performant. Let's say we had like humongous numbers to deal with or whatever. But in this case, since this is pretty much the only lookup we're going to be doing, and we will be sorting, it does make sense to just use an array. So we'll just change our code here for that check, and we'll just use our array for the rest. So let's just make that here. This will become our digits. There we go. And now what we need to do is check how many zeros and how many. Oh. Yeah. Let's see. So as you go through the arrays, you could keep zeros separate. Yeah, you could do that, but let's see. Okay. We also need, okay, so let's deal with 1 first. So if, now let's first do this. Digits dot I think find value of the first element in the array where, no, find index returns the index of the first element in the array where predicate is true. No, I just want, where's that thing? What is this thing called? Slice, reverse, reduce, pop, keys, index, includes. Determines whether an array includes a certain element, returning true or false. Yeah. So does the array include A1? Because we need that. So let's start with that. And oh. Oh yeah, let's start with that now. So if we have a 1, crap. Now see, it's a bit more complicated for this, but it's okay. We'll make it work. So we'll sort it. Sorry. We'll sort it. And yeah, we'll sort it, and then I believe if we do that sort, if we don't pass in the compare function, we'll just do it if omitted the elements are sorted in ascending order. Yeah. So if we're, do we want it in ascending order first? We want it in descending order first. Because, no, we want it like that. Yep. And then we'll go, give me the index of, no, okay, first find, what was it? Digits, oh, it includes, right. Actually, index of will be good. The index of the first, yeah, that's what we want. Index of the first element in the array where predicate is true, and -1 otherwise. Returns the index of the first occurrence of a value. Perfect. Perfect. So give me the index of 1. So with the index of 1, well, we know that there is a 1. And we also know with the index how many zeros we have before it, right? Because we sorted it in ascending. So index of 1 equals index of first 1. There you go. So with that, if, what does it return though if there is no 1? Returns the index of the first occurrence of a value in the array from index is omitted. Does it return, what does it return? Index of, it returns -1 if not found. Okay. Right, so if index of first 1 is bigger or equal to, so this is 0 indexed, R1, this is, so we need 18 zeros plus the 1, so it needs to be bigger or equal to 20, right? Because normally it would be number 19, but we're 0 indexed, so 20, yeah. So if it's bigger than that, then we know we have the possibility to make our biggest possible number, and that's what we're going to do. We are going to, we're going to, now we need to switch that around. So we need to flip our array. I wish there was It would be so awesome if there was be a flip. Boom. There's another twist. But really, you're not trying to make biggest possible number. You're trying to make smallest A. You are trying to make the smallest A, but wouldn't that... well, okay, we're not trying to make the biggest B. We're trying, because we're going to need to make the smallest B possible, but to make the smallest A possible, we need to shift as many digits over to B, right? If you use all the zeros in B to make biggest, then you are leaving the bigger digits in A. You are, except that you'll have one less digit in A. So automatically, even if they're all nines, you'll have a smaller A. Do you understand what I mean? Because we're not, what I'm doing here is not just taking all the zeros, no matter how many there are, and shifting them to B. I'm only doing that if we can make the biggest possible number, 10 to the power of 18, which is the only combination that gives us 19 digits. And if that's possible, I want to have that in B, right? Because that's going to leave one less digit into A. But if we can't do that, then yeah, you're correct. Then we need to treat that differently. We want to have all the nines and the eights and all that over to B. So that's why I'm making that check first. All right, so if we can make the biggest number possible, then we make it. How do we make it? Well, I know what it is, so I could probably just cheat and say B is equal to 10 to the power of 18, and then just have that as a string. That's what I was doing before. Okay, and then I just need to remove these from my digits array. So digits.splice removes elements from an array and, if necessary, inserts new splice or slice. Slice does what? Returns a section of an array. That's not what we want. We want to mutate it. Yeah, actually remove. So start from the zero-based index location in the array from which to start, removing elements, and the delete count. Okay, so we're splicing, we're starting at 0, and we're deleting 19 of them. There we go. So that should work. So if we do have that, then great, that's what we're doing. Nope. Nope, 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 nope. Yes. Nope. Nope. No, because if we have more zeros, then that wouldn't work. So I really need to flip the array around to use that splice method. Or I could, yeah, no, I really need to flip it around, yeah. Just use shift, unshift, push, and pop. Shift. Well, if I do that, wait, shift will just removes the first element from an array. Yeah. Yeah, no kidding. But we don't want to do that because that's the same problem if there's more than 18 zeros, right? So I think the easiest way is to just sort the array the other, because we're going to need to have the array sorted the other way around, right? No, you remove 18. How? Yeah, you can pop off the other hand. Yeah, but you're not understanding what I'm saying, I think, right? Because, okay, so we've got the array sorted. So all the zeros, all the ones, all the twos. If we're popping off the zeros, oh, okay, so what you're saying is pop off as many zeros as you need, then in a separate operation, just slice off the index of the one. Is that what you're saying? Because that would work, yeah. I was trying to make it all nice and grab in one go, the one and the zeros next to it, but that might be easier that way. So we'll do that. We will do that. So, well, in that case, I can still use a slice. I can still use the slice instead of a pop and having to, or shift, and having to have a for loop. So we'll do that. So digits dot splice, starting at the beginning. We need to splice off 18 zeros. Once that's done, oh, but once that's done, no, okay. So we need to splice off the one first. Yeah, I know. I know this algorithm stuff is seldom coded in real life apps, which is why real life apps suck. REST APIs, CRUD stuff, over and over and over and over again. All right, so we get rid of the one. That's what we want to do first. Because if we don't do that, if we try to do it after, then the index won't be good anymore. Used, but most of the time the algorithm is already done. Yeah, that's also true. So first, digits dot splice and index of first one. Thank you. And we just want to delete that one. Then we go to the beginning of the index and we remove 18 zeros. All right, that'll work. That'll work. And now our B is the proper string. And then we can move on to A. Then we can move on to A. Minimize. Minimize A. Now we already have an array that is sorted. Huh. We can't have leading zeros. So you know what, I'm starting to think that my object idea might have been more useful here because how are we going to do this? So we obviously need to start with the ones, right? We need to start with the ones. What? No, with just one. If there is a one, that's going to be the first number that we have. Only one greater than 0. Yeah, so if there's still a 1 left, that's going to be our first digit. Then after that, we're going to put as many zeros as we can. Well, yeah, the first number greater than 0. You're right. Not just a 1, but whatever smallest number greater than 0 is going to be our first digit. So that's not that complicated. So let's do let some room here. Let A string. So let's do this. So keep all the zeros in one array. Might not be a bad idea. It'll be easier to deal with that way, because otherwise they're always going to be in the way. Yeah. So let's do that. Yeah, then you can pop and shift as needed. Yeah, that's true. Let's do that. So zeros. Zeros. Is that how you spell zeros? 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 I don't know. Whatever. Zeros is going to be digits. Okay, we need to do the same thing and find the we already have the index of the first one. So okay, so what we need to do to make our zeros array zeros is simply digits dot splice from the beginning up to, well, including, so our index of first one plus 1. Actually, no. That's exactly what we want because we only want the zeros. Yeah. Yep. Will splice return the removed stuff, though? Can't remember what it does. Removes elements from an array if necessary, inserts new elements, returning the deleted elements. Perfect. So this will work. We've got our zeros. Now, all we need to check here is that we have, oh wait, no, that doesn't work. What if there's no ones? Crap. Get back here for now, you. Let's change that around. So how are we going to do this? We need to find the index of the first thing that's not a 0. Or, yeah, we could use a reduce. No, that wouldn't, because we need to remove them from the array. Yeah, just iterate over it. I guess so. Push them to 0 arrays. Yeah. But don't I want them to be removed from the our digits array though? Don't I want to get rid of and just have the digits in here? So I can't just push them, I have to remove them. But if I'm iterating and removing stuff at the same time, it's going to screw up the iteration. That's no doubt. That's yeah. You can create 2 new arrays. Yeah. I'm starting to think that my idea of of using an object wasn't all that bad. Yeah. Okay. So let's do that. Fine. So let's call this all digits. And so we don't care about sorting that for now. Then let's make const const, we're going to call that zeros. Equals all digits dot. Can I do it with that? filter, I think. Oh, wait. Yep. Filter. Haha. There's always a way to avoid a frickin' for loop. Okay, so what do I have here? Digit. Digit. And then simply do digit equal to 0. Boom. We've got our zeros done. Then we're going to call that digits. All the other digits. Yeah, let's go with that. Other digits equals all digits dot filter. Basically do the opposite. Taking our digit. Good thing we don't care about performance though. Right? Iterating over that stuff like 15,000 times. Digit does not equal 0. There we go. Okay. Okay. So we've got what we need here. How do I make this check here? Now this is all going to be different. Although no, I could just keep what I had here. No, I don't want to. I would need to. Yeah, no, of course. I know. I just mean I don't need to look at the for loops. Yeah, it is cleaner. Okay. So how are we doing this here? First, we're checking that we have a 1. So if well, that's pretty simple, right? Because if we do have a 1, oh, hold on. We'll want that to be sorted too. We'll want our, yeah, sorted in order at first anyways. So if other digits, the first index is a 1, right? If it isn't, then we know we don't have a 1. So if other digits 0 is equal to 1, then what do we do again? Oh yeah, we make b that. Oh, and we also need to check that zeros is of length. What is it? Bigger or equal to how many zeros? 18. 18. Cool. Cool, 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 cool. Now we know that we can make our big number, our biggest number. So b is equal to, how did I do that? That way, 18, yeah. I was wrapping that and just going to string. To string. There we go. Okay, not bad. It's cleaner. Less lines of code. Now, if it isn't, so before we minimize A, we need to deal with the case where this wouldn't be like that. What do we do? So we need an else here. Else. We take the first. No, we just pop off. Yeah, we just pop off digits from other digits, right? Yeah, that's right. So simple as that. So B plus E, so I need a for loop, yeah. For, or do I? Yeah. And it's going to have to be I equals, let's think about this. Or you just take the last 18 even. No, you don't, because yeah, no, you could. You could do that, right? I just sort it the other way and take the first, oh, splice off the end. Yeah, but if I splice off the end the way it's sorted right now, it would be just take them from right. I don't think you can do that. Well, you can pop them off one at a time, but I don't think you can. Length minus 18. Not sure. Not sure what. Oh, for in a for loop, you mean? Or are you talking about a splice here? String right. Sorry. That came out of nowhere. Okay. String right, what is that? String right. Yeah, we do have an array. But even if we had a string, I'm not sure I know what string right is. Never heard of it. Maybe that's, you're thinking of a C# thing. Anyways. Yeah, so okay, so if we splice, it's all right, but and then we could splice it and then sort it. But why not just yeah. Oh man, I just thought of another edge case. Oh, substring, okay. I just thought of another edge case. Look, so okay, so if we implement this and we just do, let's just get the biggest 18 numbers, and that'll be our number. Great. But what if all we're left with after that are zeros? Ah. Yeah, that would be a problem. That would be a problem for A, because you can't have leading, well, you can't have a number that's composed of many zeros. And man. Okay, so maybe if we can't do this, then we should go over to A right away and minimize. No, we can't. Still can't. We need to know how much we're going to use in. Oh, but we do know. We do. That, yeah, that's right. Okay, once we've established that we can't do this here, we know how many digits yeah, we know how many digits A is going to play with, right? Because if we're saying, okay, we can't make that big number, then we know that the biggest number that B can deal with is going to be a 18-digit number and not 19. So if you take the whatever, the size of your other digits array minus, oh no, that wouldn't work too. The size of all your all digits array minus 18. Then that's the amount of digits that you get to assign to A. And then you can minimize A. And then afterwards, take what's left over and deal with B. I think that would work better. Let's do that. So let's do font size of A. We determine that by doing I'm going to need to have this here. Let's put it here. Size of A equals, we'll just initialize that to 0 for now. And then here, size of A is equal to all digits dot length minus 19. That's what we got left for A. Otherwise, else. Size of A minus 18. Ah, crap. What if there isn't 18 digits? Oh, man. Oh. Okay, so how about that? Boom. So if you have less than 18, just use 1. Will that work? You're gonna have to make me code this OO. I was just following along. Cool. Right. What's the behavior of this OR here? I forget. Because I think negative numbers in JavaScript are not falsy. Are they? 0 is falsy. But I don't know that negative numbers are falsy. So that might not work what I'm trying to do here. If it's 0, then we'll get the 1, but if it's minus something, then we're screwed. So how about this? Is equal to all digits length minus 18. Is bigger or equal than 1. Use a ternary here. Ugh. Then yeah, go ahead and I'm definitely going to rewrite this later. And just give me that. And if it isn't, just give me 1. Yep, so it'll work for now. Okay, so now we know how many digits we can deal with in A. And we already have our sorted array. So we just pop off or whatever it's called. Just take the first index, and we shove that in A. So A plus equals other digits dot, what is it again? Shift, I think. Remove the first element from an array and returns it. Yes, please. Shift. Good. So that's taken care of. Once we've got that done, we check to see the zeros. So A plus equals basically all of our zeros. Nope. No, not all of our zeros, because there might be more than what we can deal with. Wow, I didn't expect this puzzle to have all these if and else's and all these branching conditionals and stuff. So I've got my first digit taken care of. The next logical part really is to shove as many zeros as we can in there. So let's do that. I feel like I need to document the stuff because... So, okay, first digit is the smallest number bigger than 0. Then shove as many zeros as possible in A without busting length, allowable length. How do I do that? Well, I've got my size of A. So let's call it size. Size of A. Busting size of A. So how do I do that? Size of A minus 1. Let's do that because we already have one digit here. So we could potentially... All right, let's check the size of the zeros. If 0, no, we're going to do that here. Const size, or just length, I guess, length of zeros equals zeros dot length. Okay. Yeah, well, it's not a function. Okay, now if length of zeros is smaller or equal to size of A minus 1, then go ahead and shove them all in there. Shove them all in A. Oops. Okay. And the easiest way to do that would be to go zeros dot what is that called? There is something to make an array into a string. String? No, that's not what I'm thinking of. Join. As all the elements of an array separated by the specified separator string. Yeah, yeah, and we don't want to have one, so there we go. Yeah, exorcisms format is awesome. If only I could get my exercises mentored in, quicker than 2 months. How am I running the tests local? Are we talking about exorcism here or about code and game? I'm basically by hand. I'm writing the tests using their test cases. So which is not that much work, right? I just go in here, look at their test cases, gives you the input, gives you the output. So I just use that. Then I get to run them locally. It's not that much work. Yeah, I do manually write them. But they're usually very simple tests because the input is always, you know, a string and the output is always a string. So they're pretty straightforward. Okie dokie. So what I was doing. Okay, I'm shoving all the zeros in there. Oh, but if I do that though, I should be removing all the zeros at the same time. Oh, why don't we do that? Zeros dot length equals 0. Boom. How's that? I've taken all the zeros. Now, if length of zeros is not smaller, then we need to just take the ones that we can. So we'll make that an else. So what would we be doing here? We'd be, I guess I should just pop them off or splice them, right? Splice them. So A plus equal zeros dot splice. They're all zeros, so I don't care where I start. Let's just start at 0. And we need size of A minus 1. That's as many as we want. And we're splicing that. That returns an array of the stuff that we are now going to join to our string like this. There we go. So you have to add jest to your project also. But I guess you do that for the whole project and just do folders. Okay. Yeah, that's exactly what I'm doing. Thought it would be simpler that way. I've got this set up as just one big repo. But I have a package.json for each folder because, in case I want to bring in some kind of dependency that's just related to that particular project. But probably could have had just everything on the root level. I think it's because I didn't start off that way. I started off with each puzzle being like their own repo, and I figured, nah, I don't want to have 16,000 repos. Sure, do it in C#. Do it in C#. Did you sign up for a coding game account? Cool. So we'll be able to compete Because I'm doing just the practice puzzles right now, but there's also a whole side to coding game, which is you're competing against other coders. You're building bots and stuff like that, AI that plays games, and that your bots compete other people's bots, and there's a leaderboard, and that's pretty cool. What do we have here? Get training, katas, last right time, next time. What am I looking at here? Oh, okay. That didn't quite work out. No, I guess not. Formatting's not that great for that stuff. All right, so now that takes care of the zeros. All that I need after that is to, okay, I'm definitely going to need to separate this in functions. Got it in Slack. Let's go take a look. Oh yeah, okay. Nice. Oh, you even have subfolders for each different site. That's pretty cool. Testing. Okay. So I've got the zeros. Okay. I've got the leading number. I've got my zeros, if there are any. If there's else. Oh, what if there is no zeros at this point, though? Smaller or equal. If length of zeros is smaller or equal to size of a minus 1, but bigger than 0, right? And bigger than 0. Do that. Else. But we also want to, so I'm going to need to have a, yuck. Got this monstrosity of if statements here. All right, so if we've got zeros, but we have less than the maximum size. I'm not doing this right, am I? If length of zeros is equal, that's what I have to do. No, that's not right. Length of zeros is bigger than 0, but is smaller. Oh, this is what I need here. Is equal to size of a minus 1. Then I take all of them. Boom. We're done. If it's not equal, else if length of zeros is smaller than size of 1, size of a, I mean, then I just take what I need. Well, why don't I just do that? That would take the entire thing, right? I don't need this if thing. I just need this to be smaller or equal. Like that. Forget you here. Just go with that. Okay, that's better. That is better. And then we might as well have this in the same. Okay, forget this, forget that. Much better, I think. Oops. Let's see. So if length of zeros is smaller or equal than size of a minus 1, yeah. And length of zeros is bigger than 0, then we get to take some zeros. Yay, okay. Next, we take, our digits are already sorted. So we take or fill remaining space of A with smallest numbers in digits. That sounds right. So how do we know how much space we have left in A? Well, we just go, okay, we're going to call that remaining space in A is equal to size of A minus A dot length. So we should probably call this something else. Maximum. No, it needs to be exactly that. So what could I call this? Yeah, I'll just leave it like that for now. Maybe something will come to me. So remaining space in A, size of A minus A dot length. Okay. Now that I have that, I can just do A plus equals wife brought me watermelon, so I am a bit behind. That's a good excuse. I just had watermelon yesterday. First time this year. Priorities, indeed, indeed. So, okay, we take our other digits and we splice starting at 0, and we're taking the remaining space in A. Boom. And I believe that takes care of our A. Yeah. That takes care of our A. Now we can move on to minimize B. Minimize B. So this should be called just check if B can have 19 digits. Because that's really the purpose of this thing here. Okay. Yeah. I just thought of something. Will that take care of the case where it's also possible to have 10 to the power of 18 in A? I believe it will. Yep, because if there is a 1, we're starting with the 1. And then we're shoving as many zeros in there as we. Yep, okay. So all that's left is to minimize B, which should be essentially the same process, right? First digit is the smallest number bigger than 0. That's what we're going to need to do here. So B plus equals, oh wait, how do I, no, I have to make sure I'm not overriding this here. But would I, no I wouldn't. Now you go to Google for interview and you have to solve 3 of these in 1 hour. Go, no pressure or anything. Well, if that's really what they get you to do, I'm not sure I would want to work there. If that's how they evaluate the worth of a programmer. Well, I guess it depends what you're applying for. But it wouldn't make sense to judge a programmer's worth, a software developer's worth, only based on that and the speed that he can do it, if what you're hiring him for is to frickin' deal with CRUD apps, right? Now, of course, if he's like going to be programming the next rocket for SpaceX or something or whatever, then maybe you want him to be really good at that stuff, but. Okay. Plus other digits dot shift. That's right. Then shove as many zeros as possible without busting size of A. But in this case, we don't care about busting size, because if we do bust the size after doing this, then it's because we've got too many digits anyway. So, and we're going to be checking for that afterwards. So shove as many zeros as possible in B. That's what we're going to be doing. We still have to make sure there are zeros though. Zeros. Well, I guess that's kind of superfluous. I don't really need to check that anywhere else here. I can just straight up use the zeros dot length. Zeros dot length and zeros dot length. So let's just do that too. If we just need to make sure that it's bigger or equal to, no, that it's bigger, zeros dot length is bigger to 0, bigger than 0. As long as it is, then just take everything in there, shove it in B. Okay. And then, once you're done with that, you fill the remaining space of B. Space of B with the smallest, well, actually, Fill the rest. Fill B. Fill the rest of B. B with the smallest number in digits, whatever. I understand what I'm trying to do. Actually, just take the other digits. Oh. Splice 0. I'm going to need to join that here. Almost forgot. This here returns the actual string. This here returns the string array, which I am joining into a string. That's good. Splice here, I'm okay. Then other digits. Basically all of that stuff here. Oh no, not even. Just other digits dot join. Give me the whole thing. Boom. Whatever's left, I take in B. Okay, now all that's left to do is check to make sure that A or B are not bigger than 10 to the power of 18. So if A dot, let's make it a number, parse int, parse int A is bigger than 10, 18, or parse int B, same thing, 10 to the power of 18. Then we need an output. We need an output. So let's let output equal empty string. If it is, then return. Actually, I don't think we need. I could just do it in the if statement. LB. And return -1, -1. Can't wait to try this, and it won't go. It won't work, and I'm gonna have to debug this. Okay. Otherwise, I return taking bets. Yeah. I am willing to bet against myself on this one. Simply, what are we supposed to do? We're giving to A and then the space, then we're feeding B. What are odds of success on first submission? Very slim, I would say. I would say very, very slim. But, okay, so this is our all-encompassing rearrange string function. Let's just run it for fun. See what happens. Oh! Dude! It works! Well, anyways, for those two test cases. For those two test cases, it works. That's interesting. Now let's try another test case. The next one would be maximum B. All the skipped ones are the other puzzles. Because the way I set it up, and I couldn't figure out like a way to configure when running jest. because it's a bit complicated, but essentially what I'm doing, I'm running the tests using a Jest plugin that allows the test to run on the TypeScript without having to first build or transpile it to JS, right? So I'm not testing the JS built code. I'm really testing the TypeScript code. And because of that, it's kind of complicated to make it as a per folder thing. So it tests the whole repo. I just ignore the ones I'm not working on, which is really easy with Jest. You just put a little X, boom, next to your test suite, and it's going to skip it. All right. All right. What's the next test? Actually, before I go ahead and do that, why don't we try it right here? Hey, wait a minute. That's not my code. That's because I'm probably not. Well, it should be building it. It didn't, so I'm doing something wrong here. Nope, I'm in the right place. Oh, right, it's because I don't have main doing its thing. Gotta hook it up to main first. So we're getting that's our string here, so basically pretty easy stuff. I just need to go rearrange string. Give me your S in there and just console log that out. Simple as that. Boom, don't need you. Oh, that should have built automatically or not. Oh, right, because I stopped it. You can't paste the TypeScript. To what? Oh, in coding game? No, it doesn't work with TypeScript. Only works with JavaScript. So that's why I have to build it first. I build it automatically into the dist folder, and I've got coding game, the IDE, hooked up using this here, external editor thing, hooked up to my file. And there you go. See? Bloop. And let's try it. Pass, pass. No! Crap. Crap. Oh, that's interesting. I was close, though. 0, undefined, 0. Oh, so close. All right, so let's bring that test case in. And I guess, oh, I'm just about done. So I guess that's going to be our task for tomorrow. Debugging this. Yeah, undefined sounds like an off by 1, definitely. Maximum. I was going to say shouldn't be too hard to debug, I think, but I'd rather not say that. Okay, so, oops. Yep, time's up. I'm just going to set this up here, and that's going to be it for today. Stick with the schedule. That's what I'm trying to do. I got 1 minute left. Just prep that for tomorrow. Okay, and I'm expecting this. Here we go. Peace out. I will finish it in C# and get test project Achura set up so maybe I can play along more. Cool. All right, man. See you tomorrow. Probably. Maybe. I hope. Take care.